Occasionally, you'll see some trig proofs that involve using your sum and difference identities to verify them. So that's what this video is going to show us how to do. All right, I have two proofs for us here. Remember, with a proof, you're going to show every step and you're going to justify it out to the side. So for the first one, we have the cosine of pi halves minus x equals the sine of x. Remember that you want to try to work with the more complicated side and make it match the simpler side. So to do this, since I have a difference right here, I can let this be u and this be v, and I can come over here to my cosine difference formula and write that out. So this would be cosine u, so cosine pi halves, cosine v, cosine x, plus sine u, so sine pi halves, times sine v, which would be sine x. And then remember, I'm just going to keep on bringing that right-hand side down each time, although I'm not doing anything to it. My justification for this one, I used a difference identity since it was subtraction. All right, from here we want to simplify what we can. If you'll notice right here, cosine pi halves and sine pi halves, those are things that we can replace with what we know about the unit circle. So remember, pi halves in the unit circle is straight up. So the cosine at pi halves would be 0. In other words, the x value straight up at pi halves is 0. So we can replace that with 0 times the cosine of x plus, same thing here, the sine of pi halves is the y value straight up. The y value straight up is 1. So my justification here, I'm just going to put unit circle because that's what we used to get those values. And now we know that 0 times anything is just 0. So that is gone. And 1 times sine is just sine. So we have sine x equals sine x. And we've proven it. Right here we can put simplify or multiply, because technically we multiplied by 0 to get rid of that. Either one of those would be fine. So this is a fairly easy proof. Even though the identity is kind of long, the proof turned out to be easy. All right, let's look at number 2. Same type scenario, except now we have two things that we're going to have to expand. Okay, so u and v for that one, and u and v for that one. All right, so let's start with sine addition. Sine addition is right here. So it's sine u, which in this case would be sine x, cosine v, so cosine y, plus cosine u, which is x, and sine v, which is y. Okay, so that takes care of this first one. Now we're going to move to this one. So plus, now I'm going to my subtraction formula, since this is a subtraction here. Sine u, so sine x, cosine v, cosine y, minus cosine u, which is cosine x, sine v, which is sine y. Okay, equals, and I'm going to bring down this side, 2 sine x cosine y. And I don't have much room, but I am going to go ahead and put, we used a sum and a difference identity, a sum here and a difference here. So I'm just going to put sum difference ID. Okay, now let's see if there's anything we can do with that. Hopefully you notice that right here and right here you have a cosine x sine y, and then you have a negative cosine x sine y. So those are going to cancel each other out. So that's what I would do next, is mark those out. All right, so we're left with sine x cosine y plus sine x cosine y equals 2 sine x cosine y. Now I'm just going to put cancel out here, because that's all we did was cancel two terms out. And from here, these are the exact same terms, so we can combine those and make two of them. Whenever you're doing things like this, when you're canceling things out and combining things, make sure, especially with these sum and difference identities, that they match exactly. It doesn't matter if they're both sine and cosine if the variables were messed up. So make sure it's sine x, cosine y, cosine y. The variables have to match and the trig has to match. And these do. So I can put that together and say that we have two of those. So 2 sine x cosine y, 2 sine x cosine y. And for your justification, we added those together. So you could put add, you could put simplify. Either one of those would be fine. So again, not a hard proof, even though it looked like it was going to be long to begin with, everything worked out nice.